Right, BGP. We have undergone 2 classes of introduction to BGP. We earlier saw BGP is an application layer protocol that has got rich metrical attributes, which is very important and best suitable protocol between the borders. That's why the name is also given as border gateway protocol. We learned like it's a path vector routing protocol. It shows the autonomous system path via which the routes are being learned. This path can be tuned. This path can be altered by tuning the attributes. Usually the protocols pick up a path as a best path based on bandwidth or delay or hop count. But BGP is the only protocol that waits for you to tune an attribute that suits your policy. So best protocol between the borders is BGP. So if a path is selected based on bandwidth, then what if an attacker router provides a better bandwidth? Then all our traffic will go via attacker's path. That's why we should not focus on bandwidth. We should focus on the neighbor address, with whom we are forming neighbor. We need to authenticate the neighbor, and then we need to check certain parameters. That's what we call as policies. And then we need to have a path. To have all these things, only BGP can support. So BGP is a routing protocol that works between borders. Path vector protocol, which uses TCP 179 and so on. All these things we learned in the previous class. We also learned what are all the different ways we learn route when we have multi-homing scenario. Here we see enterprises 65500 having 2 ISPs as an upstream, 2 ISPs. When we have redundant ISPs, this ISPs, the redundant ISPs that we have, we can use it as per our policy. Like we may have ISP A as primary and ISP B as secondary, or ISP A to reach all our remote branch offices and ISP B to reach the rest of the world. Or we may use ISP A to take all the time sensitive traffics like voice, video, and rest of the traffics via ISP B. Or we may have some important customers. For them we will take traffic via ISP A. For the rest of the customers we will take traffic via ISP B. So we may have all these things in our mind. These are all called as policies. To apply this policy in path selection, to make these routers know what you think in your mind, we need attributes. BGP has got that attributes to allow us tune and achieve what we want. So when we have multi-homing, the redundancy will be there, plus because you're going to share loads, not all the time, sometime you will like to share some traffic on ISP A, some traffic on ISP B. So because you share some load, the performance also improves. Not only that, as we spoke earlier, the western side countries may be having shortest path via ISP A, the eastern side countries may be having shortest path via ISP B. So when you choose multiple ISPs, we can have the performance improved. Fine. Now when we are having this multi-homing scenario, ISPs provides route information so the customer, the enterprises, can use the route and reach the external networks. It may be like this: route, just a default route provided. So when we have default route provided by D and E, now path taken will be via B because the IGP cost is lower. If you see between C and B, there is only one link. But between C and A, there are two links, so the cost will be high. This is one example. When you got two ISPs providing us default route, two ISPs providing us default route, we choose one based on IGP cost. This is one example using IGP cost. We may have some other policy also, or we may be having partial routing table, meaning for some customers and for some remote offices we will have a precise route given by ISP, and for the rest of the world, for the rest of the network in the internet, a default route will be given. So what's the advantage? You don't need to learn all the millions of routes from ISP. Just your own 10,000 routes are given by ISP. Only 10,000 routes. This itself is too much, right? Other than this 10,000 destinations, to reach those other destinations, we got this hello line, default route. So this is like partial table. Next, complete routing table is provided by the service provider. Passes all prefixes to our edge router. We call this A and B as customer edge router, CE router, customer edge router. This is also CE. And X and Y as PE router, provider edge. So these are the various fashions in which you can learn routes from the provider. One is default route, another one is partial and default. The last one is the full routing table. And then we learned what autonomous system means here. In BGP, autonomous system means multiple routers work together with single policy. with single objective. Group of routers. See, in an organization, all the routers have got one common objective. What is that? Provide the best service for our traffic. Provide the best service for our traffic. Our company traffic should be given good attention. That's the main aim of every router in our organization. Will our router focus on the neighbor's network, neighbor's traffic? No. Neighbor traffic, neighbor will take care. So we all have one focus. All our routers in an organization have got one single objective. To achieve that, there will be single technical administration. Same thing, I put it in a different word, objective. Single technical administration. Technically, it is the same administration for all routers. Then they all form one autonomous system. The group of routers that have got one common policy is one autonomous system. We learned the difference between IGP and BGP. Please understand, IGP is not IBGP. I did not say IBGP. I said IGP. It is said IGP. IGP are the protocols that are meant to be a routing protocol within the organization, within the enterprises, within the autonomous system. So within the autonomous system, we may have BGP, we may have OSPF, we may have ISIS, we may have RIP. Those protocols that are meant to be within the autonomous system are called as IGP protocols. And this protocol that we are learning is BGP, which is meant to be between autonomous system. Why? Only then you can bring down only then we can learn the routes of other autonomous system into this autonomous system. So we need a protocol in the border to receive the routes from the neighbor autonomous system and give it to inside, and vice versa. IGP will not go and bring it from the neighbor autonomous system. Can I have OSPF instead of BGP here? Well, you can have. Route will be taken and given to you, but you will not be able to have those policies that we were talking. We need a protocol that has got attributes to have policies in between different companies. There is a need for policy-based path selection. So definitely BGP is the only protocol that can take the route of this autonomous system and give it to this autonomous system. And internally OSPF, EIGRP will work, and again BGP will take from here and give it to here. So that's how the routes get distributed all around the world. Within a company, the routes are distributed using IGP protocol. But between companies, between ISPs, between different enterprises, between different clouds, it is the BGP, the protocol, the well-suitable protocol. You can also use OSPF, but they cannot choose the path as per the policy, because the metric of OSPF is only cost based on bandwidth. That is not a suitable protocol. BGP is the only protocol. BGP is used between the borders. Now, whether it is IBGP or whether it is IGP or BGP, they all exchange a loop-free routing. BGP is a path vector routing protocol. BGP is a path vector routing protocol. What does it mean? When BGP advertises networks, see, these networks are advertised from here, and I know it is advertised via this one. How do I know? Because when the advertisement comes, I also get the path information. It says this autonomous system 64512 has received it from 64520, which is this one. And that has received from 64600, which is this one. And the originating autonomous system is this. Whereas IGP will simply advertise the network and the metric. So these are the things that we spoke earlier. BGP is an AS by AS protocol, and only when we have multi-homing, only when we have an autonomous system as a transit, only when we have some policy in controlling the traffic that enters in and leaves our autonomous system, we need BGP. When you are having single home, not multi-home, single home. If you have single home, what does that mean? If you have only one ISP, you don't have any policy, do we? You got only one ISP. What policy you will have? If you have more than one, you will have policy. Okay, you go this way, you go that way. But when you have only one ISP, you cannot say you go this way and you go that way. Where is the other way? And there is no other way. When you have only one ISP, there is no policy, then there is no need for BGP. When we got limited knowledge on BGP, I know BGP just to enable, configure. Then you should not go for BGP. Why? BGP doesn't work based on bandwidth or delay. So it's not like OSPF. OSPF, you simply enable OSPF, it starts working. Wonderful, praise the Lord, hallelujah, finish. That's not the way BGP. BGP is not going to pick the path as OSPF does dynamically. BGP waits for you to configure attribute matching your policy. So you need to know attributes very well for the path selection. So when we don't know how to tune those attributes, we should not go for BGP. We ourselves will be a problem for our network if we enable BGP with limited knowledge. BGP will pick one path. When you don't tune attribute, it will pick one path based on some attributes which suits that environment. We will talk about that later. So that may not be the best one. So it is always good to know BGP in depth, then go for BGP as a solution if necessary. Otherwise don't do. The last point, lack of memory and process power. If our routers are not strong enough to handle those packets of BGP are carrying a lot of attributes, and when a packet is received, not just the route with metric is received, a lot of attributes come along with that, which is going to consume more processor and memory. If our device don't have that enough of processor and memory to handle such a big updates from BGP, then we should not enable BGP. BGP may be available as a service, as a feature, but we should not go for it if we think that there is going to be too many updates and routers will not be able to handle them. In such scenario, if you want BGP, you may go with this option, like allowing only the default route. If you try receiving all prefixes, like 1 million prefixes, not every router will be able to handle that big. We also learned that BGP is an application layer protocol that works on layer 7 of OSI. So when a BGP packet negotiates with a remote neighbor, we only configure neighbor manually. So with the neighbor, it will go and negotiate. When it negotiates, it uses TCP 179 to tell that I'm looking for BGP. BGP's reserved port number is 179. And there is no periodic update. We got a triggered incremental update. So whenever a change happens, only the change is triggered to every neighbor. Now, keep alives or the one which is maintaining the neighbor. After forming neighbor, how do you know the neighbor still exists? Because I know I'm receiving the keep alive every 60 seconds from my neighbors. That proves that they are still alive. So periodic keep alives. How often? Every 60 seconds. Every 60 seconds, all the neighbors must say hi to all other neighbors. Periodic keep alive message to verify TCP connected. Next, BGP has got a rich metric called path vector or attributes. Rich metric. You can call it as attribute. That's the right way to say. BGP's metric is attribute. So, if you see this protocol is not going to dynamically discover neighbor. Not dynamically. It won't dynamically discover neighbor. It won't choose the path just like that. It provides the flexibility for us to tune the path as per our policy using attributes. What does all this says? It says this is the best protocol for internet. We also saw that there are 3 different types of tables in BGP. You see, the neighbor table will have neighbors, list of neighbors, with whom BGP has established a 3-way connection and formed BGP peering. And next, the BGP table will have the destinations and all possible paths to the destination, multiple paths to the destination, along with the attribute attached to each path. So, based on the tuning of your attribute expectation, one of the paths is going to be taken as the best path and put it into the routing table for every destination. So 3 tables: BGP forwarding table or BGP table, a routing table, and the neighbor table. We also saw that there are 4 different types of packets. One is open message, the other one is keep alive, the other one is update message notification. Open message is sent, as the word says, open, immediately after 3-way handshake between 2 routers. Immediately after 3-way handshake between 2 routers, the very first packet will go, the very first BGP packet will go, which is called as open packet. That open packet will go and tell the neighbor that I'm coming from this BGP router ID this, my hold time is this. What is the hold time? 180 seconds. How often the keep alives are sent? 60 seconds. Hold time is 180 seconds. Next is the keep alive. Keep alives are sent every 60 seconds. Updates. Updates are sent whenever there is a change. Updates are sent whenever a new network is added with the attribute, path attribute for those networks. Without update, the routes can't be distributed. Open message will not carry route information. Keep alive will not carry all the route information. It is only the update carries the route information. Next is the notification. When error is detected, see, when will the notification go? Only when the error is detected. So immediately after sending a notification saying a network is gone down or something like neighborship policy change, something like that, when an error is detected, the BGP connection closes after this notification is sent. So before closing the BGP session, the last packet to the neighbor is what called a notification message. Accidentally, if a neighbor goes down, it'll just shoot out the notification message and then it will go down, so that the receiving router will know that the neighbor is no more available. We should not wait. It need not to wait till the time expires. I say the whole time is 180 seconds. It need not to wait 180 seconds for the time to expire. It can take the decision at once the notification is received. Right, so about these things we spoke in our previous class. So far we have done a quick revision on what all we learned in last two classes. So now let us get into this fresh topics of BGP. This BGP, though I said it is border gateway protocol, it works between the borders, this is also enabled inside the autonomous system to carry those external network inside. See, if you learn routes from one autonomous system to your autonomous system, it will be only between the border routers, but you may need those external routes to come into all the routing tables of inside router, for which we make use of the same BGP instead of redistributing into our OSPF. Please understand what I am saying. We have IGP protocol as OSPF already. Yeah, we already have OSPF. But we don't enable OSPF between borders because they don't have attributes. We use BGP to take the routes from here to here. So from the other autonomous system, the route updates are coming along with the attribute. I want this route, this network, let's say a network to reach 80.000. So I'm learning it here, 80.0.0.0 on C router. But what if someone wants to ping from here? Someone is here who wants to ping 80.0.0.1. I want to ping this. So what we need is, we need this route from C to be given to B, so that B can advertise it to A, B can advertise to, let's say, K. We want this along with the attribute. See, if I take from BGP here and give it to OSPF, this AT network will now travel as OSPF network because I redistributed. But when it travels as OSPF, will there be attributes? No. OSPF don't understand attribute. So all the attributes that was coming from this autonomous system to this autonomous system getting lost, then there is no point of having BGP. So what we do, we simply enable BGP. We keep OSPF for our inside networks. For those networks coming from outside, we keep BGP, so that BGP itself will give to this router. So between C and B, we call it as IBGP because it is within the autonomous system, within our autonomous system. When we are forming BGP between two routers that are in same autonomous system, in order to carry the external routers to our internal routers, we do this. We are not replacing OSPF. Understand? We are not replacing OSPF. OSPF job is to take care of our networks, inside networks. BGP running on this router is only running to bring those external routes inside along with the attribute. So those BGP peerings are called as IBGP peering. IBGP neighbors, internal, within the autonomous system. This BGP that is between C and A, between two different autonomous systems, are called as EBGP, External Border Gateway Protocol, Internal Border Gateway Interior Border Gateway Protocol. So a BGP peer is also known as BGP neighbor. So neighbor, peer, both are same. You may use any one. BGP peer is also known as BGP neighbor. Is a specific term that is used for BGP speakers that have established a neighbor relationship. As I said earlier, BGP uses TCP, no? So to form BGP neighbor, the very first thing is the TCP connection. Once the TCP connection is formed, they send the open message and then keep alive and then update, and then they get synchronized. That is how the neighborship is established. That is how BGP peering is done. BGP peers, BGP neighbors, both are same. So what is peer? Peer is a neighbor. What is neighbor? If two routers can do three-way handshake, followed by open message, BGP open message, sending the router ID and the hold time, and the keep alives every 60 seconds, and the BGP update packets between them. If they can do all this thing, we call those two routers as BGP neighbors, BGP peers. As we saw earlier, the BGP running between autonomous system, in order to bring the other autonomous system network inside this autonomous system along with the attribute, we call that BGP as EBGP, External Border Gateway Protocol. External Border Gateway Protocol. There's a condition for forming neighbor if you're doing eBGP neighborship. What is that? That neighbor need to be directly connected. You will understand the depth of the meaning, depth of the meaning when we do the lab. What does that mean? Neighbor need to be directly connected. Meaning, is this two directly connected? Of course they are directly connected. This is not complete meaning, this is okay for now. So eBGP neighbors need to be directly connected. See, the word default is used, which means there is an option for you to have neighbor even if it is not directly connected. IBGP. The BGP that is working between the routers that belong to same autonomous system. And this neighbor need not to be directly connected. Do not have to be directly connected. Meaning, I can form neighbor with A and C without having BGP in B, which is not possible in OSPF. If I want OSPF, I need to run on here, here, here. But BGP, no BGP here. I got BGP here and BGP here. I can still form neighbor using the reachability which is already provided through OSPF. Because BGP is TCP, this is possible. So when a BGP is running between neighbors within the same autonomous system, it's called as IBGP, Internal Border Gateway Protocol. The neighbors do not have to be directly connected, do not. For eBGP, need to be.